Hello viewers, today we are presenting a new topic, deployment of models in artificial intelligence. Let's start. Finalize the trained model objective. Ensure that the trained model is ready for deployment by meeting performance standards and preparing it for reproducibility. Performance evaluation. Description. Evaluate the model's performance on validation and test datasets to ensure it meets required metrics. Validation matrix. Depending on the problem type, classification, regression, etc., assess metrics like accuracy, precision, recall, F1 score, RMSE, etc. Comparison. Compare the model's performance to baseline models or benchmarks to validate its efficiency. Model serialization. Description. Serialize the trained model to save its parameters, architecture, and pre-processing steps. Serialization formats. Common formats include Pickle for Python-based models, HDF5 for deep learning models, or ONNX for interoperability across platforms. Include pre-processing steps. Save any pre-processing steps, that is scaling and coding, along with the model to ensure consistency during deployment. Version control. Description. Implement version control to track changes to the trained model over time. Use of version control systems utilize tools like Git or SVN to manage model version, track modifications, and collaborative with team members, document changes, improvements, and performance updates with each version to maintain a transparent development process. Reproducibility. Description. Ensure that the trained model can be produced reliably in different environments. Environment setup. Document the environment setup including libraries, dependencies, and configurations necessary to run the model. Reproducibility tests. Test model reproducibility by training it from scratch using the saved parameters and pre-processing steps. Model interpretability optional. Description. Enhance model interpretability to understand its predictions and decision-making process. Techniques. Use techniques like feature importance analysis, SHAP values, or LIME, local interpretable model agnostic explanations, to explain model predictions. Documentation. Document model interpretations to aid stakeholders in understanding and trusting the model's predictions. By finalizing the trained model, ensuring its performance, and preparing it for reproducibility, you set the stage for successful deployment into real-world applications. This step lays the foundation for subsequent stages in the deployment process. Choose deployment infrastructure. Objective. Select the appropriate infrastructure where the model will be deployed, considering factors like scalability, computational resources, and cost. Infrastructure assessment. Consideration of options. Evaluate various deployment options such as on-premises servers, cloud platforms, AWS, Azure, Google Cloud, or edge devices. Scalability requirements. Determine the scalability needs of the model to accommodate potential increases in workload or data volume. Computational resources. Assess the computational power required for model inference and any additional processing needs. Cost analysis. Cost comparison. Compare the costs associated with different deployment options, including infrastructure setup, maintenance, and operational expenses. Scalability costs. Consider how costs may scale with increased usage or resource demand over time. Budget constraints. Ensure that the chosen infrastructure aligns with the budgetary constraints of the project or organization. Security and compliance. Security considerations. Evaluate the security features and compliance standards of each deployment option to ensure data privacy and regulatory compliance. Data sovereignty. Consider geographical restrictions or data residency requirements that may impact the choice of deployment infrastructure. Vendor support and services. Vendor reputation. Assess the reputation and reliability of potential infrastructure providers, including their track record in providing support and services. Available services. Consider additional services offered by cloud providers such as managed machine learning services or serverless computing options. Model packaging. Objective. Package the trained model and its dependencies into a deployable format, making it easy to set up and run in various environments. Dependency management. Identify dependencies. List all dependencies required to run the trained model, including libraries, frameworks, and runtime environments. Version control. Ensure that dependencies are version controlled to maintain consistency across different deployments. Containerization. Choose container platform. Select a containerization platform such as Docker for packaging the model and its dependencies. Create Docker file. Write a Docker file specifying the steps to build the container image, including installing dependencies and copying the model files. Model packaging. Include model files. Include the serialized model files and any pre-processing scripts or configuration files required for model inference. Packaging instructions. Provide clear instructions for building and running the Docker container, including any environment variables or parameters needed. Testing and validation. Container testing. Test the Docker container to ensure that the model runs correctly within the containerized environment. Integration tests. Conduct integration tests to verify that the containerized model interacts correctly with other components or systems. Documentation. User guide. Create a user guide or README file detailing the steps for setting up and running the containerized model. Deployment instructions. Include instructions for deploying the model container in different environments, such as local development machines or cloud platforms. By choosing the appropriate deployment infrastructure and packaging the model into a deployable format, you prepare the model for deployment in real-world applications, ensuring scalability, ease of deployment, and compatibility with various environments. Implement deployment pipeline. Objective: set up a deployment pipeline to automate the deployment process, ensuring consistency, reliability, and efficiency. Continuous integration (CI). Source code repository. Use a version control system, that is Git, to manage the source code and model files. Automated builds. Configure automated build processes triggered by code commits to ensure that the latest changes are integrated smoothly. Unit testing. Include unit tests to verify the correctness of code changes and model updates. Continuous deployment (CD). Automated deployment. Set up automated deployment pipelines to deploy the model to production or staging environments after successful builds. Deployment strategies. Choose deployment strategies such as blue-green deployment or canary releases to minimize downtime and mitigate risks. Rollback mechanisms. Implement rollback mechanisms to revert to previous versions in case of deployment failures or performance issues. Testing and validation. Automated testing. Integrate automated testing frameworks to perform various tests, including unit tests, integration tests, and end-to-end tests. Validation checks. Include validation checks to ensure that the deployed model meets performance criteria and behaves as expected in different scenarios. Quality gates. Set up quality gates to prevent flawed builds from progressing further in the deployment pipeline. Monitoring and logging. Monitoring tools. Implement monitoring tools to track the health, performance, and usage of deployed models in real time. Logging. Configure logging mechanisms to capture relevant information and troubleshoot issues during deployment and runtime. Integration with production systems. Objective. Integrate the deployed model with existing production systems or applications, ensuring compatibility and seamless interaction. Data input output formats. Format compatibility. Ensure that the deployed model accepts input data in the required format and generates output in a format compatible with downstream systems. Data transformation. Implement data transformation processes if necessary to convert data between different formats or structures. Communication protocols. API development. Create APIs, application programming interfaces, or endpoints for interacting with the deployed model. Standard protocols. Use standard communication protocols such as RESTful APIs or gRPC for seamless integration with production systems. Security measures. Implement authentication and authorization mechanisms to secure model endpoints and protect against unauthorized access. System integration testing. End-to-end testing. Conduct system integration tests to verify the interaction between the deployed model and other components of the production system. Scenario testing. Test various usage scenarios to ensure that the integrated system behaves as expected under different conditions. Documentation and training. User documentation. Provide documentation for developers and users on how to interact with the deployed model, including API endpoints, input-output formats, and users' instructions. Training. Offer training sessions or workshops for stakeholders involved in using or maintaining the integrated system. By implementing a deployment pipeline for CI/CD and integrating the deployed model with production systems, you ensure a smooth and efficient deployment process, allowing the model to seamlessly interact with other components of the production environment while maintaining reliability and scalability. API development optional. Objective. Create an API to facilitate interaction with the deployed model, enabling other systems or applications to send input data and receive predictions or responses. Framework selection. Choose a web framework suitable for API development, such as Flask or Django for Python-based models or Express.js for Node.js-based models. Endpoint definition. Define endpoints for sending input data and receiving predictions or responses. Example endpoints. Predict for making predictions, health for checking the API health status, docs for API documentation. Request handling. Implement request handling logic to parse incoming requests, extract input data, and pre-process it if necessary before passing it to the deployed model. Ensure error handling for invalid requests or input data. Model integration. Integrate the deployed model into the API endpoint logic to perform inference on incoming data. Deserialize the model and load it into memory for making predictions. Response formatting. Format the model predictions or responses according to the specified output format, such as JSON or XML. Include relevant metadata or information in the response, such as prediction, confidence scores, or error messages. API documentation. Generate API documentations using tools like Swagger or Postman to provide developers with information on how to interact with the API endpoints. Include details on request, response formats, endpoint URLs, parameters, and example usage scenarios. Deployment to production environment. Objective: deploy the packaged model to the chosen infrastructure, that is cloud servers, edge devices, using the deployment pipeline, and monitor the deployment process for any errors or issues. Deployment configurations. Configure deployment settings such as environment variables, network configurations, and resource allocation based on the production environment requirements. Deployment pipeline trigger. Trigger the deployment pipeline to deploy the packaged model to the production environment automatically after successful testing and validation in the staging environment. Continuous monitoring. Monitor the deployment process in real time using monitoring tools and dashboards to track the progress and identify any errors or issues. Set up alerts for critical events or performance anomalies during deployment. Rollback mechanism. Implement a rollback mechanism to revert to the previous version of the deployed model in case of deployment failure or unexpected issues. Test the rollback process to ensure its effectiveness and reliability. Post-deployment testing. Conduct post-deployment testing to validate the functionality and performance of the deployment model in the production environment. Monitor key metrics such as response time, throughput, and error rates to ensure the model's stability and reliability. By developing an API for the deployed model and deploying it to the production environment, you enable seamless interaction with the model from other systems or applications while ensuring reliability, scalability, and maintainability. Monitoring the deployment process helps identify and resolve any issues quickly, ensuring smooth operation of the deployed model in production. Testing and validation. Objective: thoroughly test and validate the deployed model in the production environment to ensure it performs as expected and meets performance requirements. Test scenarios. Define test scenarios that cover various use cases, edge cases, and potential failure scenarios. Include both positive and negative test cases to validate different aspects of the model's functionality. Sample data generation. Generate sample data or use simulated scenarios to mimic real-world conditions and inputs. Ensure the sample data represents the range of inputs the model is expected to handle. Test execution. Execute the defined test scenarios against the deployed model in the production environment. Record and analyze the outcomes of each test case, including model predictions and responses. Validation criteria. Define validation criteria based on performance requirements, business objectives, and user expectations. Verify that the deployed model meets these criteria and performs within acceptable limits. Error handling. Validate the model's error handling capabilities by intentionally introducing errors or invalid inputs. Ensure the model provides appropriate error messages or responses in such scenarios. Performance monitoring. Objective: set up monitoring tools and alerts to continuously monitor the performance of the deployed model in the production environment. Matrix selection. Choose relevant performance metrics to monitor, such as prediction accuracy, response time, throughput, and resource utilization. Select metrics that align with the goals and requirements of the deployed model and the broader system. Monitoring tools. Use monitoring tools and platforms, that is Prometheus, Grafana, Datadog, to collect and visualize performance metrics in real-time. Configure dashboards to display key performance indicators, KPIs, and trends over time. Altering mechanisms. Set up altering mechanisms to notify stakeholders about performance anomalies. threshold breaches or critical events. Define alert thresholds based on expected performance levels and acceptable deviations. Continuous monitoring. Continuously monitor the performance of the deployed model, ensuring that it meets service level agreements, SLAs, and user expectations. Regularly review performance metrics and trends to identify potential issues or areas for optimization. Root cause analysis. Conduct root cause analysis for performance issues or anomalies detected during monitoring. Investigate underlying factors contributing to performance degradation and implement corrective actions as necessary. By testing, validating, and monitoring the performance of the deployed model, you ensure its reliability, stability, and effectiveness in the production environment. Continuous monitoring enables timely detection of issues and proactive optimization to maintain optimal performance over time. Versioning and maintenance. Objective. Implement versioning to track changes and updates to the deployed model over time and regularly maintain and update the model to adapt to changing requirements, data distributions, or performance issues. Version control. Utilize version control system, that is Git, to manage code, configuration files, and model artifacts. Tag each deployment with a version number to track changes and updates. Change management. Document changes and updates to the deployed model, including bug fixes, feature enhancements, or performance optimization. Follow a structured change management process to review, approve, and deploy updates. Model retraining. Schedule regular model retraining intervals to incorporate new data and adapt to changing patterns or distributions. Monitor model performance over time and trigger entertaining based on predefined criteria or thresholds. Performance optimization. Continuously monitor the performance of the deployed model and identify opportunities for optimization. Implement optimizations such as algorithm improvements, feature engineering, or parameter tuning to enhance model performance. Documentation and training. Objective. Document the deployment process, including setup instructions, API documentation, and troubleshooting guides, and provide training and support for stakeholders interacting with or managing the deployed model. Deployment documentation. Document the deployment process step by step, including setup instructions for deploying the model to different environments, that is, deployment, staging, production. Include details on infrastructure requirements, dependencies, configuration settings, and deployment procedures. API documentation. Generate comprehensive API documentation covering endpoints, request response formats, authentication mechanisms, and usage examples. Provide detailed descriptions and usage guidance for each API endpoint to facilitate integration with other systems or applications. Troubleshooting guides. Create troubleshooting guide for frequently asked questions to help users diagnose and resolve common issues encountered during model deployment or usage. Include troubleshooting tips, error codes, messages, and recommended solutions for common scenarios. Stakeholder training. Offer training sessions or workshops for stakeholders involved in interacting with or managing the deployed model. Cover topics such as API usage, data input, output formats, model interpretation, and troubleshooting procedures. Support channels. Establish support channels, that is, email, forums, ticketing systems for stakeholders to report issues, ask questions, or request assistance related to the deployed model. Provide timely responses and resolutions to support requests to ensure a positive user experience. By implementing versioning, maintenance, documentation, and training practices, You ensure the reliability, scalability, and usability of the deployed model over its life cycle. Continuous improvement and support mechanisms help maximize the value derived from the deployed model and facilitate seamless integration into business process. Security considerations. Objective. Implement security measures to safeguard the deployed model and data, addressing potential vulnerabilities and ensuring continuous protection. Access controls. Role-based access control (RBAC) define roles and permissions to restrict access to the deployed model and its resources based on user roles and responsibilities. Last privilege principle. Grant users the minimum level of access required to perform their tasks, reducing the risk of unauthorized access. Encryption. Data encryption. Encrypt data at rest and in transit to protect sensitive information from unauthorized access or interception. Secure communication protocols. Use secure communication protocols, that is HTTPS, to encrypt data transmitted between clients and the deployed model. Authentication mechanisms. User authentication. Implement user authentication mechanisms, that is username, password, multi-factor authentication, to verify the identity of users accessing the deployed model. API authentication. Secure API endpoints with authentication tokens or API keys to control access to the model's functionality. Regular security audits. Conduct regular security audits and vulnerability assessments to identify potential security weaknesses or loopholes in the deployed model and infrastructure. Automated security testing tools and manual code reviews to detect and address security vulnerabilities proactively. Patch management. Establish a patch management process to regularly update software components, libraries, and dependencies used in the deployed model to address known security vulnerabilities. Monitor security advisories and apply patches promptly to mitigate the risk of exploitation by malicious actors. Data privacy compliance. Ensure compliance with data privacy regulations, that is GDPR, CCPA, by implementing data protection measures such as anonymization, pseudonymization, and data minimization. Obtain necessary consent from users for data processing activities involving personal or sensitive information. Secure logging and monitoring. Implement secure logging mechanisms to record and monitor user interactions, system events, and access attempts for auditing and incident response purposes. Configure monitoring alerts to notify security terms about suspicious activities or anomalies in real time by prioritizing security measures such as access controls, encryption, authentication, regular security audits, and compliance with data privacy regulations. You can mitigate security risks and protect the deployed model and data from potential threats and breaches. Continuously updating security protocols and staying vigilant against emerging threats are crucial for maintaining the security posture of the deployed model over time.